Howdy everyone, it's Miss Kosh. I wanted to talk through a few highlights on this activity. Hopefully you've already done it. Hopefully you have filled out the chart and you're not just relying on me to do it for you. But I do want to make sure you walk away with the key points that you really need to make sure you understand. Okay, so first of all, I have, where did it go? I have desmos open and I have the sine curve. So notice if I come over, I can hit play on the A value. You'll notice that it's a vertical stretch, which A would always be a vertical stretch. But what it's doing there is it's changing the amplitude. Okay, so what the absolute value of A, let's hit pause for a second. Right now, my A value is this 8.58, and so the amplitude is how high it's going. So this value right there is that 8.58. That the A value is the amplitude. If it had been, let's pause when it's negative. Oh, what did I do? Okay, right here, I now have the A value as a negative 8.43. The amplitude would still be that positive 8.43. So what we want to write down on our chart is, you could write vertical stretch. You probably already know that. I mean, it's not a bad idea. Vertical stretch. Okay, what happens is that the amplitude is going to be equal to the absolute value of A. Okay, if A is negative, then you'll notice back here that it reflected. So instead of going up between 0 and pi over 2, oh, you know what? We could change that. We can label this by pi over 4 and oh, nice. Okay, oh, pi over 4, enter. Will that do it? Okay, oh, there we go. Okay, so instead of it going up between 0 and pi right through there, it's going down. So there was a reflection and a stretch. Okay, so let's come back to where this is equal to 1. Oh, no. Okay, sorry. There you go. Now let's investigate the next thing. So what does B do for our graph? Well, so B is a horizontal stretch or shift, which is good to know. But the important thing, what it's doing for us, is it's changing the period. Okay, so what we will say here is that B changes the period, and so the transformed period is now, well, initially sine and cosine, this works for both of them. I just gave you one graph because they behave in an almost identical way. But the transform period is going to have, it's now going to be, well, okay, that's what I was trying to say. Sine and cosine initially had a period of 2 pi. And so what happens here is B will stretch that. And the bigger B is, the more compressed your graph gets. So let me come back here and show you what I'm talking about. Notice my B value is, well, the negative doesn't tell you a whole lot, but notice as B gets really, really big, there's tons and tons of, it gets really, really compressed. Okay, see how that's adjusting in there. So what we're going to do is our period is 2 pi over B. Our transform period is equal to 2 pi over B. Okay, coming back, we want B to be equal to, well, I can't seem to line it up just right, so you have to watch me type in 1. Okay, now let's see what happens with C. So notice with C, the amplitude didn't change, the period didn't change, but everything is shifting left and right. And when you think about what you know about equations, the C is going to shift you left to right. So this would shift left to right, just like it would in other situations. And what do you expect to happen with D? Well, oh, okay, let's go back to, there's 0, nice. With D, it's going to obviously shift us up and down, which is kind of fun. Okay, so that's that first one. Shift. I would argue that up and down, that C and D are pretty easy to understand what they're doing. It does make it a little more complicated when you deal with pi over 2 and all of a sudden you're shifting it left pi over 6 and then you have to remember how to add and subtract fractions. But practice, practice, practice. Okay, looking at the next one, I have transforming tangent. So I didn't do sine and cosine because they behave in a similar way. So first one, notice with A right here, it's a vertical stretch, and it's kind of boring, to be honest with you. So yeah, it's a vertical stretch. To be honest, I don't really, what I care about is, hang on, let's come back to where we want to be. There it is. What I care about is that you got the zeros in the right spot, and so that's, oh, you can't see what I'm pointing to. That's where it changes concavity. So it's the inflection point. I care about that, where it changes concavity, and I care about its asymptotes. So when A becomes something out here, well, yeah, it's stretched, but I'm not overly thrilled by that. What I tend to do when I write the test and quiz, I tend to either have for tangent and cotangent, I either have a, hang on, delete, oh, that's not what I wanted, there we go, okay. I either have A equal to 1 or negative 1, because that does a cooler thing, you can see that reflection. But here, once again, oh, I skipped to, okay, vertical stretch, and I'm going to write, meh. I tend to, if I write the problem, I'm going to have A equal plus or minus 1, to be honest with you. Because other than that, I don't really care what those other points are, and so to stretch it that way isn't really thrilling. Other classes, other teachers, IB, your pre-calc calculus test that's written by somebody else, they might change A, but that's what I tend to do. Okay, let's look at B. So with B, when we hit play, whoa, holy moly. Okay, so it changed the period also. That's ridiculous. So what happens though is that tangent and cotangent, the parent function has a period of pi, not 2 pi. So the transformed, so we could say the new period, that was a shorter word to write, is equal to pi over b. Okay, and then this one, yes, it's going to shift left and right, just like it would in the other ones. Now you got to pay attention to your asymptotes. Those are going to shift and that sort of thing if you have a C value. And then D would obviously shift up and down. And that's going to change where your inflection point is. So that's going to change the place where it goes from, they look sort of, that was kind of terrible. But it'll move this point, and that's the one that I care about. So really, I care about this. You can't see what I'm pointing at. I care about this point, and I care about these asymptotes on either side. That's what I'm most concerned about you labeling correctly for me. Okay, and now let's go look at secant and cosecant. It is kind of fun and silly to make all of these start playing at the same time. Oh, except, so if you make all of them play, I'm easily amused. Holy moly, I don't even know what we're looking at. But okay, stop the insanity. Okay, let's look for cosecant. Now with cosecant, when I change my A value, notice, okay, if A is negative, we have reflected. Do you see how the red has now reflected over the x-axis? So if it's negative, it's reflected. If it's positive, it didn't reflect. But on all of these, well, let's see. If I'm here, I can find that point. Notice that's that 4.6. It matches. And down here it would be a negative 4.6. So we don't have amplitude with secant and cosecant, but what we do is this is where I use our little British example of mind the gap. That A value will stretch things. A value can stretch the gap. Okay, so it's going to go whatever that A value is. So in this one it was 4.6. So now it's going to have this relative minimum at negative 3 pi over 2, comma a positive 4. It's this one that I was looking at. And then we're going to have a relative maximum here at negative 4.6. Okay, let's come back to, what do we need to be at? 1? There, oh, dang it, I should just stop trying. Not in life in general, in that situation. Okay, then, once again, B changes, yikes, B changes our period. Notice, I don't know if you can tell this, but it's not affecting the center asymptote here at 0. Okay, so it didn't change that. Everything's kind of getting pulled and stretched away from the y-axis. And then C, oh dear, I should do one at a time. C shifts everybody. Oh, good grief, hang on, let's bring this back to 1. And now you can see that it's shifting just left and right, that the appropriate amount. And then, of course, let's go back to 0. And then, of course, D shifts us up and down. Okay, so coming back here, this one is where we have to, it's still a vertical gap, or vertical stretch. I'm too lazy to write it again, but this is where we have to mind the gap. And if we don't have any shifts up and down, then the range would go from, that's a soft bracket, negative infinity to negative a, and then we'd pick it up again from a to infinity. But I don't know that I want to write that every time, because if I have a shift up or down, then that's going to change my range. So I don't know that I want to, you know what, I don't want to write that down. But it's true if all you do is stretch it. And then this one would have, it would transform the period. The new period would be 2 pi over b, because secant and cosecant have a period of 2 pi. This is going to shift left and right. That's an F, pretend. Left or right, depending, just like you would have always done. And once again, it gets a little tricky. If you were supposed to have an asymptote at x equals pi over 2 plus pi k, and then you shift to the right pi over 6, well, then this now becomes x is equal to pi over 2 plus pi over 6 plus pi k. I've never written it this way. I usually just clean that up. That's 3 pi over 6 plus 1 more pi over 6 is 4 pi over 6, which would be equal to 2 pi over 3 plus pi k. Okay, so you would have to, if you shift left and right, you've got to be able to go from here to here, or whatever the situation may be. Okay, I don't want that to stay in the notes either. But I was, oh, that's going to be too much. Well, delete. Okay. Down. Okay, and then this one, ooh, right. Okay. And then this one is going to shift you up and down, just like the others. So really and truly, what gets complicated with these is when you first change the period, and then you have to shift left and right and find those new values. So you really need to practice. It's all the stuff that you've done before, but the details get a little sticky. Okay, I'm gonna send you to some of the videos that I made in the past, but now you should have a filled out chart. Good luck.